So he says, according to the fundamental theorem of algebra, which polynomial function has exactly 8 roots? So I'm going to have, I think I did something similar to this problem, like on Thursday, I want to say. But this looks very, very similar. So I need 8 roots. So my first problem here is I have 8x cubed minus 5x squared minus 6 times 7, 6x to the power of 5 minus 2. So for this, let's solve them all each. So I have this one here. What I can do is I can simply just I can multiply this term by this term to get basically what my highest order of polynomial is. So if I'm multiplying exponents, I can simply just add, right? So 8 times 7 here is 56, and 3 plus 5 here is simply 8. So my highest polynomial has 8 roots, which means this solution, this option here is correct. Let me prove to you that the other ones are wrong first. So this is 15x cubed plus 4x plus 1 to the power of 5. Again, for this one here, I have 15x cubed and then it's to the power of 5, right? So if I have to the power of 5, what I'm going to do is I'm going to multiply the exponents here. So I have 15 to the power of 5, which is quite a big number. Let me just check that. That's whatever, 7759375. And this is x to the power of 15 here. X to the power of 15 does not have exactly 8 roots, which means the solution here is wrong. Let's look at C. This is x squared plus 13 to the power of 6. Again, I can simply just multiply my exponents because it's exponent to an exponent, right? So this here is x to the power of 12. This solution here is also wrong because it doesn't have, I need the polynomial to be exactly 8 roots, right? And then finally, I have 7x to the power of 7 minus 5x to the power of 5 plus 3x cubed times 2x squared plus x. And then simply, I can multiply the first term by the first term here. So 7 times 2 is 14, and then x to the power of 7 times x to the power squared. I can add the exponents to get 9 here. The polynomial is 9, not 8, which means this option is also wrong here. So A here is my correct solution in this problem. So let me just see if they got this question right. So they did. Option A is the correct answer. So any polynomial of degree n has exactly n roots counting multiplicity. That's good. So we have, so 8x squared times 7x to the power of 5 is 56x to the power of 8. That's good. B here, it says I have exactly 15 roots, right? So I have x to the power of 15 here. So I have exactly 15 roots. C here has 12 roots because I said that x squared to the power of 6 is x to the power of 12. And then finally, 7x to the power of 7 times 2x squared would give me 14x to the 9, and they said 9 roots counting multiplicity. So the solution here is correct. Correct. Good analysis. Solution is correct.